was this leg right here? Yeah, just by looking at the cosine, I know this is x over what? R. So negative square root of 3 over 2. When you think about it, guys, if I did cosine of this, I would get that. So this is the true angle. And what I'm saying when I say true angle, it's this angle. Okay? But that's your reference. This side has to be what? 1. Because sine is y over what? R. Okay, so fill it in. Cosecant is going to be what? Say again? 2. Because it's the reciprocal of sine. The sine is right there, by the way. Secant is what? Say again.
-2 over 3
Over 2? 3. Okay. And really, for this one, are you just basically flipping this? Yeah. And you're going this way? Okay. Tangent is what? Jaden, what is it?
Negative square root of 3 over 3.
Okay, negative square root of 3 over 3. And again, that comes basically from saying opposite over adjacent. Cotangent is what? Gage? What? Negative root 3? Okay, good. That's review, right? Okay. The hardest part of that problem might be just what? What? Getting started, yeah. How about just knowing where the angle is? You have to know you were in quadrant 2. And the only way you're going to know that is by looking at the sign of, is this positive? Yeah, so sine is positive here, here. Cosine is negative here, here. So it's this quadrant that we doubled up on. Okay? Good? Okay. Now, is this the next slide? Okay, but I'm going to go back. I'm going to go back to like where it says using, somewhere around the bottom here. On yours it says basically this. Chapter 5, Analytic Trigonometry. Definition, it's the branch of trig that deals with the properties and relations of trigonometric functions. Okay, you have a whole bunch of trig identities. Now, I can just say this is what they are, or we can quickly prove it. And I'd like to take 3-4 minutes just quickly prove it. So would you guys buy into this a little bit? Either you can watch it, or you can copy it. I don't care. But I want you to go back to the unit circle. Just draw yourself a quick unit circle, okay? On that unit circle, we know the radius is always going to be 1, correct? Yeah. Okay. This point on the circle is just a point. It's x, comma, y. I've already done all this with you, so you should be saying, this looks familiar. Okay, see this triangle here? This is your right triangle. This is theta. Tell me this distance from here to here. How far is this? X. And then tell me this distance. Y. Okay? Rings a bell? Okay. Tell me this. Cosine of theta equals, and sine of theta equals. Cosine equals adjacent over hypotenuse. What does it equal? X. Sine equals? Y. Tell me what tangent equals. Okay, y over x. Yep. Everybody agree? Okay. Would you guys tell me if you were doing the Pythagorean theorem right now with that triangle, the Pythagorean theorem would tell us to write what? Okay, the Pythagorean theorem, if this is a right triangle, then what relationship holds here? X squared, leg squared plus the other leg squared equals what?
1 squared.
Equals 1 squared. Can I just say 1?
Yeah.
Okay, now, here's the deal. A lot of stuff comes from what I just wrote up here. So what I'm saying to you is this. You know how I said x squared? Well, guess what? X is really just what? X is equal to what? Cosine. So you know what you could say instead of x squared? You could say cosine squared. I should put theta here. Okay, instead of saying y squared, what can you put? Yeah, y is sine, right? So you could say sine squared. So here's what happens, and by the way, 1 is a constant. It's not going to change. So really, the Pythagorean theorem translates into this. This is one of your identities. Look at your sheet. This is called the Pythagorean identity. Cosine squared plus sine squared is always going to equal what number? 1. Okay? That is on your sheet. But there's more. Do you see more of them underneath? Okay, where did the other ones come from? Let me show you. This is where they came from. If I took this Pythagorean identity and I took it and divided by cosine squared, if I did that everywhere, what would happen? Okay, what's cosine squared divided by cosine squared? No, it's not 0. It cancels and becomes 1. It's like saying it's 5 divided by 5, 6 divided by 6. It's just 1. Plus, okay, this one's going to be hard for you because I haven't done something. Hang on. I should have gone over here. We know that x is cosine, y is sine. What do we know about tangent? Tangent's y over x, but tangent could also be what? Yeah, it could be sine of theta over what? Cosine of theta. Is this one of your properties?
Yes.
Yeah, I think it's your quotient property. So guys, if you ever see tangent of theta, can you just replace it with that? Yeah. See, you're going to do a lot of substitution here. You're going to substitute what you see, and you go, I don't want that. I'll take that instead. Or I don't want this. I'll take this instead. Okay? So if I do this to you, can you guys finish one more for me? What would this be? Cotangent of theta would equal, yeah, but it's y, x over y, which is what? Cosine of theta over what? Sine of theta? Okay. I'm just trying to show you where these properties come from. That's all I'm doing. I don't want to just say, here they are, but this is where it came from. It basically came from your unit circle. Then we come over here and we answer this question. If I took the Pythagorean identity and divided by cosine squared, I get 1 plus. What do you think that is? Sine squared over cosine squared. Sine over cosine is what? Yeah, tangent squared. Yep. Whoops, tangent squared of theta equals 1 over cosine squared. Now, one thing I didn't say is the reciprocal functions. Look at, they're in the middle. I never talked about them, but that's because I think most of you, probably all of you, know the reciprocal of sine, cosine, tangent. So if I say 1 over cosine, that's the same as what? Secant. But it's squared, so it's going to be secant what? Secant squared. Isn't that another one of our properties?
Yes.
Yeah. So here's a property. Cosine squared plus sine squared equals 1. If I divided everything by cosine, I get this. This is another property, or identity. Well, guess what? The other one comes when you divide by what? Sine. So let me just erase this, and I'll just put what down here instead? I'll put sine down there. So if I go sine squared, and sine squared. Okay, what's cosine squared over sine squared? It's cotangent squared. Okay, so here comes another identity that you can use. Cosine squared plus sine over sine, 1 equals 1 over sine squared. Look at the reciprocal one. Yeah, it'd be cosecant, wouldn't it? Okay. Hey, are you going to have to memorize these? I hope not. Well, guess what? You're not going to. That piece of paper I gave you will stay with you until when?
End of the year.
May 31st. Good job. Yes. Don't lose it. Otherwise, I got to keep digging them out, and I don't know if I can ever find these. Okay, good? Okay, there's probably something else I didn't talk about. Oh, yeah. I didn't talk about even and odd functions. I just want to ask you, do you guys remember, even functions? Even functions were symmetrical to what? Y, ooh, good job. Somebody said it. All right, so is this is a parabola at the origin, vertex at the origin, is that symmetrical to the y-axis? Yeah. So if this point is on there, 2, 4, over here you have what? Negative 2, 4, right? Okay, so basically what changes?
The X.
Yeah, if you plug 2 into your function, you get 4. If you plug negative 2 in, you get what? Negative 4. So basically, oh, I'm sorry, I said that wrong. If you plug negative 2 in, you'll get a same answer, 4. So when you think about it, guys, here's what really happened. Okay, so if all that's different is the x value gets changed to negative 2, really we can do this. You guys remember just changing the x? Okay, if I did this from here to here, you're going to get the same answer. It doesn't matter. I can put 2 in, I'll get 4. I can put negative 2 in, I'll get 4. So when functions are even, they're symmetrical to the y-axis, which means you can just switch the x variable, and you'll get the same answer. All right, now what does that mean to you? It means any one of those trig functions up there, see that? Those trig functions, if they're symmetrical to the y-axis, they're even. Now, what's symmetrical to the y-axis? Which one is this? Is that sine or is that cosine?
Cosine.
That's cosine. So cosine, would you agree, is symmetrical to the y-axis? Yeah. So what they're saying to you is this. If you take cosine of x, it should equal cosine of what? Negative. Thank you, Santa. Thank you. Anyways, that's your property. Are you looking in that even odd property one? Yeah. Okay. Yeah. Anyways, yes or no? You see it?
Yep.
Okay. Right where you see it, where you put down that cosine of x equals cosine of negative x is a what function? It's even. And you should put that down because you'll at least kind of remember. Even means symmetrical to what? Yeah, this is symmetrical to the y. Okay, that's probably all I'm going to talk about it, but I will say this. Cosine and secant are reciprocal functions. So if I graph secant, secant would be symmetrical to y. It's the same thing. Okay, now look at all your other functions right now. What do you notice? Okay, you're not saying anything. Ready? Sine of negative x equals sine of x? No. Negative. Okay. What happened was the x got switched, and when you put it in front of your function, it's like the y got switched. So if the x and the y got switched, it's a what function? It's odd. And what does odd even mean to you? Symmetrical to what? Origin, yeah. Okay, so what is symmetrical to the origin? Sine is, and it's reciprocal, cosecant. And then if you look over there, you guys, you could probably tell tangent and cotangent are symmetrical to the origin. So they're both the same. Hey, do you really need to know that? No, I was trying to prove to you why this is equal to this. Why are they equal? Because they're odd and symmetrical to the origin. That's the only reason. Now, after today, do you really need to know that? Not really, but it's nice to know why they exist. Okay? All right, can we start? Okay, here we go. This is a full period, don't worry. Okay, here we go. This is our first one. Simplify this expression. Use the fundamental identities to simplify these trig expressions. Okay, so here's the deal. You get words and you're supposed to simplify them. Well, it's like saying this is cosine of an angle, and you're multiplying it by what? Tangent of an angle. Well, it's easy if it's 3 times 4. I know the answer is 12. But what's cosine times tangent? Who remembers what your teacher said last year? Okay, it's weird. I heard you say that, Jason. You said weird, right? Well, here's the deal. It's weird because you don't see things that cancel out. Because really that's all it is. Everything has to cancel. So what I would tell you guys is this. Try make everything the same trig function. I got a cosine and a tangent. How do we do it? If you can get them to be all cosines and sines, perfect. Okay, do you guys know what tangent is? Yeah, it's just sine over what? Sine over cosine. Okay. All right, cool. Times cosine. And by the way, this is a number. That's just a number. Put it over 1. Now, here comes your algebra 1 skills. When you multiply two fractions, what do? Straight across. But if there's something in common on top and bottom, do what? Cross them out and say the answer is sine of x. We got it. We're done. So Jackson said, my teacher told me to make them all what? Sines and cosines. If you can get them all to be sines and cosines, life is nice. But that doesn't always work. Sometimes you have to make them all tangents or cotangents or something like that. But most of the time I go back to sine and cosine. Okay, I don't think you can see this one, right?
Yeah.
Oh, you can? Okay, look at it. All right. When I start seeing the number 1 and some kind of function squared, I think, which identity? Whenever I see 1s and something squared, I think the Pythagorean identities. Okay, are you looking in the Pythagorean ones? In the Pythagorean one, you have cosine. Don't you have this? Cosine squared plus sine squared equals 1. But you see this? 1 minus cosine? What does 1 minus cosine equal? Sine squared. Okay, how do you know? Because if you got this to be 1 minus cosine, that means you subtracted it over to that side. What's left? Just sine. Oh, so really this is just what? Sine squared. Yes? No? Guys, you have to manipulate your formulas and say, I want this formula to look like what I have. Well, I move the cosine over and it says sine squared. Oh, 1 minus cosine squared is sine squared. And then I still got to multiply it by what? Okay, get this in your head right now. If I say x, it could be theta, theta. If I say theta, theta, it could be xx. Okay, I don't like what I see, so what are we going to do? Yeah, cosecant is 1 over sine times sine squared. Okay, this is over 1. See, sine squared is really what though? Isn't it just sine times sine? Okay, so sine times sine over sine, cross out, what's left? Just sine. That's the answer, guys. Sine of x, sine of x. Okay, so we got the same answer twice in a row. Are you okay? All right, I'm just going to slide it up. Here we go. What's it? It's ugly. It's ugly. I get it. There's one thing I don't like right off the bat. What about you guys? Yeah, who wants a cosine of negative x? Look at your identities. Look at your, is it the odd even identities? Cosine of negative x is the same as what? Just cosine of x, isn't it? So could I just replace, oops, I'm just going to replace cosine of negative x with what it's equal to, and it's equal to what? Cosine of x, okay. times what? Sine squared of x. Okay. What do you think? Say it again, John. Is it just sine squared the answer? No. Well, maybe. It might be, I don't know, but I'm asking you, where did you get that from? You don't know it. Okay, wait, raise your hand because I got 3 people talking. Okay, here's what I'm going to ask you to do. Watch this. You see this cosine of x? Think of it as a number. Let's call it x minus cosine of x times sine squared. Well, sine squared can't be x. It's got to be some other variable. Let's make it y squared. Okay, if you had that problem and I said simplify it in Algebra 1, what would you do? You'd stare at it, go to the next one. You can't add them. They're not like terms. You can't do it. Say it again. Divide by x. Well, you're kind of right, Abby. How about if I say it this way? Don't divide by x. Factor out an x. Can you factor out an x? What would it be? X times what? 1 minus y squared. Well, if that is called simplifying, then I can do it here too. What would you factor out? Yeah, why don't you take out a cosine? Because they both have cosines in it. Okay? Cosine of x comes out, right? And then what's left? 1 minus what? Sine squared. Oh, well, look inside now. Doesn't it kind of have that Pythagorean look? It's got a 1 and it's got a trig function squared. It looks like one of the Pythagoreans. Okay, so this cosine, stop, thank you. This cosine stays put. Okay, what's that? Cosine squared, got it. Right? And that just says cosine times cosine. What's the answer? Louder. Cosine cubed. Yeah, that's it. Okay. Does everybody agree that this 1 minus sine squared is cosine squared? Do I have to prove it to you why? No? Okay. And this says cosine times cosine times cosine. That's why it's cosine cubed. Yes, this is weird, but you've got to bring it back to what? Bring it back to algebra. Look at this. This is algebra 1. Now this is pre-calculus. It's the same thing though. Nothing's different. Except you have to really think hard about what they're saying to you. Okay? Can I move on? Okay. Okay. So does factoring really help us here? I just factored out the common factor. It does help. Rewrite each expression as the product of 2. Product of 2 just means factor them. Okay, I want something times something. So 1 minus cosine squared. Will you please factor? I'm not going to say anything. Go back to algebra 1. And you like your numbers and you like your variables. I know that. Okay, let's go back to algebra 1. How do you factor x squared minus 16? What times what? X what? X minus 4 times x plus 4. Guys, this is the difference of 2 perfect squares. Yeah, x minus 4 times x plus 4. Okay, would you please look at this? Is this a perfect square? 1 times 1. Is this a perfect square? Cosine times cosine. Hey, it's the same thing. What's it going to be? 1 plus cosine of x times 1 minus cosine of x. Got it. Done. all I'm asking for you to do is factor, because factoring is a good tool for us to get answers. So this is just a factoring slide. That's all this is. Okay, we factored it. Let's move on. Let's factor the next one. Okay. Think algebra 1 first before you do anything.
I hate these so much.
Don't use the word hate. I dislike it.
This
Hate
is
is
the one
such a
thing I
strong
can
word.
truly say that I do hate. I feel aggressively disliked by this math problem.
There. That's algebra 1. You know it says cosecant squared? Just say x squared. You know it says just cosecant of x? Just say x. That's the problem you did in algebra 1. It's the same problem you're doing today. You guys remember how to do this? What times this is going to be 2x squared? 2x times 1x? Okay. Now, you need two numbers that give you 6, but when you do the inner, outer, you get -7. Has anybody figured this number out?
-1,
-1 here, and what?
-6.
Okay, let me check it out. Inner, -1x. Outer, -6x. Jesse, you have it right. But guess what? That's not our problem. We've got cosecants. So we're going to say what?
I know, I'm
That's
sorry.
not.
Being dramatic.
Help.
Let me be
Yeah,
dramatic.
right.
That's not right?
You didn't multiply the 2. Yeah.
Okay, this and this. Oh, that's -12x. Jesse? I'm so sorry, Jess. It's not right.
That's why I forgot I was doing my back.
Okay, let's try something else. 2 and 3? 2 is 4, 3 is... 2,
Wait,
I don't think so.
nope. So then does it even work? Does this actually work?
It should.
If it's
Why would I put it on if it doesn't?
I don't know.
2 what?
Not be 2x. If it would, yeah.
Yeah.
Oh wait, no.
2x minus, then it's a 3 and then
You want a 3?
I don't think it's actually.
a 3 there and a 2
A 3 there and a 2 there. Okay. -3x.
Ah, there we go.
That's it.
Then we all
This is -3x. This is -4x, which makes -7x. Johnny, you're the man. Okay, here we go. Put it in. Instead of saying 2x, we'll say what? So 2 cosecant of x times cosecant of x. Cosecant of x. And then negative and negative. We want 3 here. We want 2 here. Good? Okay, we got it.
This helps a lot.
Yeah, you want to go back to what you know.
Yeah.
And it's the same thing. Okay, next. Go. But before we go, we probably should talk, right? What's wrong? You guys have to look at that and say, how am I going to factor something that's got a secant in it and a tangent in it? This is going to be kind of hard.
gotta get them all the same.
Try to get them all to be the same.
Yeah, 'cause
Who knows what I should do? Go ahead, Jane.
1 over cosine squared,
1 over cosine squared.
right?
But if you say this is 1 over cosine squared, well now I got cosine and a tangent. I'm still
Yeah,
got
but then you switch tangent to sine over cosine.
Then I got sines and cosines.
Yeah.
It's gonna be hard to factor. You want them all the same. If you're gonna factor, you want them all the same.
Well, how do you get tangent?
Okay, I'm gonna give you a hint. See this? Right here? This is important that you understand. If you have a secant squared, you can get secant squared to go away. How, Abby?
1 plus tangent squared.
Yes. So you guys go to your Pythagorean identity, right? You're there, and you should see what? Where am I at here? Okay. We have secant. So secant is really tangent squared plus 1. Oh, well let's do that. Tangent squared plus 1 plus what? 3 tangent of x, oops, plus 1. Okay. Well, now that's going to be tangent squared in front plus what? 3 tangent of x plus 1 makes plus 2. Doesn't this look like the previous problem I just did with you? Okay. Think about it. You need factors of 2 that add up to 3. That should be an easy one for us. I think it's got to be tangent of x times tangent of x, right? Okay. To get tangent squared. What'd you guys put? Plus 1 plus 2. Done. You factor it. The secret is get all the words to say tangent, tangent, cosecant, cosecant. I mean, that's all you want. If you're going to factor, you want the same trig function. So work with the identities to help you get there. Are we ready? Can we move on? See that secant squared? Go to your Pythagorean identity. Look on your paper. What does secant squared equal? Help him, Johnny. Point. Are you not seeing it?
Yes.
Okay, you see it now? Everybody okay? All right. All right. Oh, guess what? In our lesson, we will have to do what? Add fractions. Okay, so this says 1 over 1 plus sine squared plus 1 over 1 minus sine. I said sine squared, I didn't mean to say that. 1 plus sine plus 1 over 1 minus sine. Combine the fractions over a single denominator, then simplify.
I do not believe that we have that problem.
Oh, you do?
We don't.
Yeah, we have 1 over cosine.
It was different.
Okay. You tell me what you got.
1 over cosine squared x minus 1.
Like this?
No,
No,
the
no,
minus
no.
1 is behind the fraction.
Yeah, behind
After the fraction.
Yep, I gotcha. Now what? That's it? Okay, sorry.
I made sure before I spoke on it.
Okay, here we go. You need common denominator. Okay, when you add subtract, think of this problem like this. Ready? 1 over 5 minus 1. How would you do it? Yeah, you'd get your common denominator, right? Okay, you'd say this is 1 over 1, so I multiply this by 5, and I get 5 over 5. And then, of course, this answer is negative 4/5. Yeah. Okay, it's the same thing. This is what? 1 over 1. Well, what would a 1 and a cosine squared both go into? Okay, let's try this. What does a 1 and a 5 go into? 5. That number. 1 goes into any number, guys, right? So, what does 1 and cosine squared go into? Whatever cosine squared is. Okay. So your common denominator is cosine squared. Okay. Well, this one you don't even have to do anything with. But this one you'd have to multiply the 1 on the bottom by cosine squared to get it to be this. Well, and same thing here, right? And you get cosine squared. Yes?
Yes.
Okay. How do we add fractions? What do we do to the denominators? Nothing. We don't touch the denominators. We never have since 2nd grade. Numerators, you just add them up, right? 1, take away what?
Cosine squared.
Oh, okay. Are you recognizing anything on the top? That is your Pythagorean identity, right? Sine squared plus cosine squared equals 1. You have 1 minus cosine squared. Get the cosine over here. And it says 1 minus cosine squared equals sine squared, yeah. Come on over. This is really just sine squared. Over cosine squared. Now that looks pretty good, except, are you recognizing sine over cosine as tangent? But because they're both squared squared, you're going to say what? Tangent squared. Yeah, done. Hey, you know when you're done because you have like one trig identity or one trig function left. This is pretty good, guys. That's a pretty good answer, but we can clean that up to make it this. This is even better. That's a better answer. You get down as far as you can to like hardly anything left. You okay? Okay, what's next? Multiply. Not that? Yes? Okay, this is our last slide, isn't it? Okay, ready? This is a tool. This is a cool tool. Ready? It's like the hammer. It's like the drill. It's like it's something in your back pocket. You pull it out. Multiply to simplify a fraction. Eliminate the denominator in this expression. Sometimes you are stuck. You don't know what to do. So you get this look where you have a binomial on the bottom. And doesn't this kind of look like 1 minus what? Sine squared? But it's not. So what we're going to do is we're going to multiply the denominator by the conjugate. You guys remember the conjugate?
Oh, yeah.
1 plus. Yeah. 1 minus sign? How about 1 plus sign? Do it. See what happens. Do it on the top. 1 minus sign. Now this is a trick. This is just a trick that will help you simplify. All right, you ready? On the top, you get this. What's this? Yep. What's this? It's like saying x squared times y. It's x squared y. You're going to say what? Minus cosine squared y times sine of y, right?
I just have a quick question. Does
Yeah.
the one you multiply on the top, does that stay negative? Like the
Well, it's positive times negative. That's why I put the negative. Right?
yeah, but
But like on the bottom, when
Bottom
you multiply,
is-
you have a positive, and then on the top,
Oh, you're right. Oh, that is not smart. Not smart. Sorry.
I just want to make
No, that's a great question. That's plus.
Sounds like
That's plus. My fault. My fault. Sorry. Sorry.
okay.
Now, on the bottom, you guys, you should remember conjugates are easy because you only have to do first. One. What about inner, outer? They what? They cancel. I'm not going to waste my time. Last times last is negative. What? Sine what? Sine squared? Got it. Okay, are you looking on the bottom? Does it look familiar? Oh, got it. Oh. I'm gonna, hey, would you just wait? Hey, stay with me. This is really what? Cosine squared of y. Factor out what? Factor out what? Factor out the common. Cosine squared, right? You'd have 1 plus what? Sine of y, right?
Yeah.
Okay, well guess what happens here and here? They cancel. Guess what the answer is? 1 plus sine. Sorry, I rushed that little last part. This is being recorded. I will put this on YouTube, and you can re-look at it tonight if you want. Hey, really quick. Tomorrow's a work day.
I walked out of here.
Okay, we're gonna work. If you don't, if you get stuck tonight, it's okay. But get started. You can.
Mr. Peter, I won't be in this class
Whew.
tomorrow.
Well, guess what? You saw the whole lecture. We're done. Tomorrow is just pretty much a work day. The only bad part is and you're not going to get any of that help. What are you going tomorrow?